Hey guys, it's Miss Johnson here, and I'm here to bring us our video for learning targets on relations, functions, and linear equations. The first example on your notes page says this table shows average and maximum lifetimes for some animals. Represent this data as ordered pairs. The average lifetime would be the X and the maximum lifetime would be the Y. So if I take a look at this table, that means that I want all of these average lifetimes to be the X values, maximum lifetimes to be the Y. And I'm going to write these as ordered pairs. So for the cat, I'd have an ordered pair. This would be my ordered pair of parentheses there. There we go. I would have 12, comma 28. For the cow, I'd have 15, comma 30. For the deer, I'd have 8, comma 20. Dog would be 12, 20. And horse would be 20, 50. So those are the 5 ordered pairs that would be represented using this table. Now, a relation is any two sets of data that are paired together. Just like a relationship is between two people, a relation in math is between two numbers. So looking at any two pairs of numbers that we can put together as ordered pairs, and then graph on a coordinate plane and analyze the data from there. So if I just look at some examples or some definitions here, the first definition we want to talk about is domain. The domain is the set of all the first coordinates of the data, or in other words, the x coordinate. It's all the x values. So domain is the set of all first coordinates in the ordered pairs. The range is the set of all the second coordinates, or the y coordinates in the ordered pair. So if I look at labeling the domain and range for our function up here, our domain would be 12, 15, 8, 12 I already have, I don't need to list it again, and 20. The range would be the y coordinates, which are 28, 30, 20, 20 I have already, and 50. And then a function, here's the special thing about a function. A function is a relation in which each element in the domain pairs with exactly one element in the range. And basically what that's saying there is that no element in the domain is allowed to repeat. No x value repeats. So that's a quick way to check if you're looking at something like this list up here, 12, 15, 8, 12, and 20. These 12s repeat, so this one is actually not a function because the domains repeat. Now it's okay if the y values repeat, not a function is what I meant to write there. Sorry about that. Not a function. It's okay if the y values repeat. We're allowed to repeat y values, but we're not allowed to repeat x values in order to be a function. So it can still be a relation even though it's not a function. A function is just a special type of relation. It has that extra category. This is another way of representing that function. They'd have a mapping diagram. You just map what x value goes with what y value, and so on. And then one way to determine if something is a function or not, especially if you're looking at a graph, is to use the vertical line test. And the vertical line test is when you drag a vertical line. When you're doing this on pencil and paper, I usually just use my pencil. Drag a vertical line across the graph, across the whole function. And you're looking for any place that the function crosses that vertical line twice, more than once. If it crosses it more than once, then it is not a function. So if I use my vertical line here on this function on the left, when I drag it across, there's no place that the red line goes over the vertical line twice. So this one is a function because I've met the requirement. Okay, but if I look at the second one on the right here, drag your vertical line across and see it's crossing two spots, two spots, two spots, two spots, two spots, almost the entire way, except for this very first one where it only has 1 point. So this one would be no, this one is not a function. So if it crosses that vertical line more than once, then it's not a function. So let's take a look at some examples here. In number 1, you're asked to state the domain and the range. So if we list the domain, typically we list the domain in braces like that. We'd have -4, -3, 0, and 1. Remember that domain is a set of all x values. And the range would be the set of all y values. So I'd have 0, 1, -2, and 2. So there's my domain, there's my range. Now, if I look at it on a graph, I want to again look at all the x values. So I'm looking at -4, -1, 0, 2, and 3. -4, -1, 0, 2, and 3. And then the range would be the y values, 3, -2, -4, -3, and 3 again. So 3 I don't have to list twice, but I have 3, -2, -4, and -3, and that will suffice. So listing out the domain and range. Now let's talk about function notation for a second. Function notation is if a relation is a function, I can replace the y with the function of x. That's what that f of x means. That tells me that it's a function. I replace that y with f of x. So you can see over here in the example, I now have f of x is equal to x squared plus 2, where it used to probably say y equals x squared plus 2. So that just tells you that it is a function. So the independent variable in function notation is always x. X is the independent variable. It's the domain of the relationship. And then the dependent variable is y, which we've now replaced with f of x. So y is going to be our dependent variable, which is usually the range. Over here in our example of function notation, what they give you is the equation, the function, and they're asking you to find f of -3. So this is like your x, and I'm going to take that -3 and I'm going to plug it into where I see x. So f of -3 equals, make sure you put it in parentheses, -3 squared plus 2, because when I square -3, I know that I get a positive 9. If you didn't put that in parentheses and typed it into your calculator is going to tell you -9. But you're squaring the whole thing, the negative and the 3. So f of -3 is equal to 11. And there we have it. Let's take a look at a couple examples on the back side of your notes page. In number 3, it says, given the following function, g of x is equal to 3x minus x squared, find the following. So part A, I want to find g of 2. So g of 2 is going to be 3 times 2 minus 2 squared. And then I just simplify that. 2 squared is 4, 3 times 2 is 6. 6 minus 4, so g of 2 is equal to 2. And what that translates into is that you have a point of your x value of 2 and your y value of 2. That would be a coordinate on that function. How about part B? Now I want g of 3 times g of -1. So I'm going to take that 3 and the -1 and I'm going to put them both into the function. So g of 3 would be 3 times 3 minus 3 squared. It's almost like we have to calculate that first, times g of -1, which is 3 times -1 minus -1 squared. Calculate that second. So I need both of these things. So over here on the left, I have 9 minus 9, which ends up being 0. And then here on the right, I have -3 and minus 1, which ends up being -4. 0 times -4, we all know, is 0. So my g of 3 times g of -1 is equal to 0. And the last one we want to plug in 3x to g. So we're going to take 3x and plug it in. That means I have g of 3x equals 3 times 3x minus 3x squared. So we have some x variables that are going to be left in our function, and that's okay. They can stay there. That's fine. So I have g of 3x equals 9x minus 9x squared. Okay, that's what's happening there. When I square the 3 and the x, I have to square them both. 3 squared is 9, x squared is x squared. So this would be our function. Technically, we could probably write it in standard form, putting the greatest exponent first. So I'd have negative 9x squared plus 9x. There's nothing else I can do with that because I don't know what x is. So I just have to leave it as it is. All right, that's going to go ahead and conclude our video for today. Thanks for watching, and I hope you guys have a great night. Don't forget to go back to Schoology and take the quiz.